This video is about synthetic division, so we're going to be dividing polynomials in this sort of fake way. So a couple of important things before we do this division here is with synthetic division, we need to know that if there is a missing term, then we have to have a placeholder. So by missing term, I mean if our biggest exponent, our degree is 5, then we should have an x to the 5th term, an x to the 4th term, an x cubed, an x squared, an x, and just a number. So if you're missing any of those in descending order, you have to have a placeholder. The second thing we need to know is that the thing that we're dividing by has to look like x plus or minus, either operation there, a number. So we can't have something like 2x plus 1. We can't have something like x squared plus 1, because neither of those are strictly x plus or minus some number. Let's get into it. So we set it up in this funky kind of way. We're going to draw an L, so it's like the opposite of normal division, and we're going to just put the coefficients of each of these terms. So just the 2, the negative 15, the negative 9. The issue is, remember, we are missing a term. So if I start with x to the 5th, I don't have my x to the 4th term. So if there's no x to the 4th, then there's 0x to the 4th, and we're going to put a 0 there. Then I'll put the negative 15, my x squared term, my x term, and my just constant. So all of those coefficients in order. The next thing that we're going to do is think about this factor over here. X plus 2 is a factor, which is the opposite of a solution. So if x plus 2 is the factor, to find what the solution is, we would set it equal to 0, so x would equal negative 2. That is the solution that goes with the factor of x plus 2. So this is sort of a side note over here. So to finish the setup, I'm actually going to put the solution of negative 2 over on the left. Not the factor, but the solution that matches it. Then we do our process. So the work of synthetic division is kind of crazy. We start by just dropping down the first number. Just drop it straight down. Then I multiply that solution, the negative 2, times the thing in the bottom. So negative 2 times 2 gives us negative 4. I write that under the next piece. Now I add straight down. So 0 plus negative 4 is negative 4. And then we do the steps again. Negative 2 times negative 4 is positive 8. I add straight down and get negative 7. Then I multiply again. Negative 2 times negative 7, which gives us positive 14. We add straight down and get a positive 5. Multiply negative 2 times positive 5, and we get negative 10. Add straight down, we get a positive 1. Multiply again, we get a negative 2. And then add straight down one more time, we get 10. This last number, no matter what it is, this is the remainder. So the way that we actually write the answer is kind of weird. If our original problem was saying take 2x to the 5th, a quintic, and divide it by this linear term, and it's always going to be linear because it has to be just x plus or minus some number, then our new answer will be an x to the 4th. So we're going to drop a degree down. So we're going to put these numbers that we just got on the bottom as our coefficients, with 2x to the 4th being the first, because we dropped the degree by 1. Then we'll get minus 4x cubed, minus 7x squared, plus 5x, plus 1. So that's just all of these coefficients corresponding to the standard form. And then the 10 is our remainder. So plus 10 over the original divisor, the thing that we were dividing by at the beginning. And this is our final answer.